Hello all, welcome to this course on Elements of Mechanical Engineering. My name is Atchuta Ramacharyulu and I am working as an assistant professor in the Department of Mechanical Engineering. Now in this lecture, where we are in the fourth module of Elements of Mechanical Engineering course, we are going to study different types of milling machines. So in the previous lecture, we have seen the basic parts of a milling machine. Okay. Suppose if this is a milling machine, we have the basic parts like starting from the base. We have base and then we have column, and upon that we have arm, which is hanging arm. Okay. And then we have spindle. Spindle is the one which is rotating along with the cutting tool. And then we have straddle. Straddle is the one which is holding the table, and upon that we have table. So like this, different parts of a milling machine are there. Now we are going to see what are the different types of milling machines and what are the different types of applications or operations that can be done on different types of machines. So in them, the first one is vertical milling machine. So when we compare different types of milling machines, we have to compare them with the help of the type of milling operation it is doing or the mill orientation. Mill orientation is the one parameter which indicates the orientation of the mill. Mill orientation means in which direction the mill is oriented. Okay. So there are two types of orientations possible: vertical milling machine and horizontal milling machine. So in vertical milling machine, we have a vertical arrangement. The tool, the workpiece, etc. are arranged in a vertical fashion. Whereas in horizontal milling machine, everything is aligned in the horizontal fashion. So let us see what is a vertical milling machine. And we have a picture here. So in the previous lecture also, we have seen different parts of a milling machine. So the different parts of a milling machine were explained on a vertical milling machine only. So that is a vertical milling machine. We can see here, this is the picture showing a vertical milling machine where we have different parts like base, on this we have column, arm, we have table, straddle, etc., spindle, etc. Many parts are there. So all these parts, this type of arrangement is called vertical milling machine. In the vertical milling machine, we have to understand some important aspects. The spindle axis is vertically oriented. See here, the spindle axis, this is vertically oriented. So it will be rotating about a vertical plane or vertical axis, and milling cutters are held in spindle and rotate on its axis. So whatever the tools, multi-point cutting edge tools are attached to the spindle, and they will be rotating in a axis which is vertical. And then the spindle can generally be lowered or the table can be raised. In most of the cases, the table can be raised up, which will contains the workpiece. The table will be moved up towards the cutting tool and machining operation is done. Okay. And sometimes the spindle also has, in some machines, the spindle can be moved down so that it will come near to the workpiece where it will remove the chipping. And or the table can be raised, giving the same relative effect of bringing the cutter closer to the deeper into the work. Okay. So moving the spindle towards the workpiece or raising the table towards the tool will give you the same effect. There is nothing difference. Okay, this will allow you to plunge, cuts and drilling. We can make drilling and cutting operations. We can do many machining operations by this vertical milling machine. And then the depth to which the blade cuts into the work can be controlled with a micrometer adjustment nut. So this is a very important aspect when we are studying vertical milling machine. We have a micrometer adjustment nut which is attached to the table. So when we are giving feed to the table, we can actually move the table upwards, or we can give the depth of cut by using this micrometer reading. So micrometer, when it is moved slightly, it can give as precise movements as a micrometer, which is used for measuring the dimensions. Okay, so the micrometer is very important. The micrometer nut is the one which is responsible for giving the depth of cut or depth of the holes which are being drilled on the workpiece. Okay, so the vertical milling machine, we can simply identify it by looking at the machine, because the spindle which will be rotating about a vertical axis. Okay, so that is vertical machine. And then the second type of mill oriented machine, that is the mill orientation is horizontal here. So here we have a horizontal milling machine, by which we can simply observe that the axis of rotation of the tool is horizontal. See here, the axis of rotation of the tool is horizontal. So in the previous lectures, we have explained about the different parts of milling machine. There we have shown the same example. It is the horizontal milling machine. So let us see some details about a horizontal milling machine and how it is different from vertical. A horizontal mill has the same sort of cutters, but they are mounted in a horizontal spindle. We can simply see from this figure the spindle. This is the spindle on which we have a yellow colored cutting tool, which is attached to the internal gear pulley arrangement with the help of a belt which is in turn attached to the motor. So everything that is rotating here will be in horizontal plane. So the axis of rotation is horizontal. And then many horizontal mills also feature a built-in rotary table that allows milling at various angles. So the table on which we can fix the workpiece, it has the capability of rotating in multiple directions. Okay, so because of that, we can do many different operations that are possible on the horizontal milling machine. This is one advantage of this horizontal milling machine, because we can have a rotatable bed which is possible only in horizontal milling machine, because it is not possible in vertical milling machine. Okay, so built-in rotary table, the table can be rotated in all the 360 degrees, where we can get multiple operations. Okay, this feature is also called as universal table. So the table which is having the capability of rotating in all the 360 degrees, the table can be called as universal table. So the universal table, it will not be present in every milling machine. That is, in every horizontal milling machine, the universal table may not be present. So it is an option which is made separately for some types of horizontal milling machines. While end mills and the other types of tools available to a vertical mill may be used in a horizontal mill. We can see here end mills and other types of tools available in vertical mills. See here end mills and some other types of tools which are used in vertical milling machine can be used in this horizontal mill also. Okay, their real advantage lies in arbor mounted cutter called side and face mills. So when we want to use side mill and face mills, like these are some of the operations which are performed on horizontal milling machine. So whenever we are using the tool that are there in the vertical milling machine, we can use those tools in the horizontal milling machine also, whereas they have to be modified according to the application. So the tools which are used in vertical milling machine can be used in horizontal milling machine also. Similarly, vice versa. The tools which are in horizontal can be used in vertical milling machines as well. So by this we can understand that both horizontal and vertical milling machines have the same kind of capability, yet depending on the particular operation, we have to choose a different machine. Either you can choose a vertical milling machine or a horizontal one. And then the real advantage, which have a cross section rather like a circular saw but are generally wider and smaller in diameter. The tools which are sometimes taken in the horizontal milling machine, which are from vertical, so they have a smaller diameter. They are generally wide because they are made for vertical milling machines. And here, if we want to use those tools which are used in vertical milling machine, we have to adjust sometimes. We have to make some modifications to the machine, or we have to adjust the movement of the table or straddle. Okay. So this is all about horizontal milling machine. So in both horizontal and vertical milling machines, the key difference is that the orientation or the axis of rotation of the spindle is different. In vertical, the axis is vertical. In horizontal, the axis of rotation is horizontal. And then we have other types of milling machines like bed mill. So bed mill, it refers to any milling machine where the spindle is on a pendant that moves up and down to move the cutter into the work, while the table sits on a stout bed that rests on the floor. Okay, now what is bed mill? So bed mill is nothing but the spindle can be operated or it can be moved up and down. Okay, so this kind of arrangement is mostly seen in drilling machines. Okay, where we can move the spindle up or down so that we can do the whole drilling operation on the workpiece. Whereas in these bed mills, what happens is the bed or the table on which the workpiece is attached, it is stable. It will not be moved. Okay, it has the opportunity or it has the configuration to move, but it is not moved. It is kept stationary, and the tool is moved up and down. Okay, these are generally more rigid than knee mill. So the knee mill, the bed mills are more rigid than the knee mills. It is very sturdy. Okay, gantry mills can be included in this bed mill category. So gantry mill, what is a gantry mill? So gantry mills are very large type of milling machines. These are responsible for doing machining operations for very large workpieces. Okay, the workpiece itself can be kept on the ground without having any attachment or without having any placement. That means we don't need any chuck here. We don't have to place the workpiece in a vise. The workpiece is so huge that it is simply kept on the ground, and the milling machine equipment is attached on the gantry. So gantry is nothing but it is a frame which is attached on a column which is very height of about 100 meters, okay, or 50 meters. So the gantry mills also comes under this bed mill because the workpiece is stationary, okay, which is the first quality of the lathe machine. See, in lathe machine, we have the workpiece which is moved. The workpiece have movement. Whereas in milling machine, the workpiece is fixed almost. Workpiece is fixed, but the bed on which the workpiece is placed, it can move in any direction. But in some machines, which are called as bed mills, the workpiece is stationary. It will not be moved along with the bed also. It is absolutely stationary, absolutely fixed at a point, and the tool or the spindle will move towards the workpiece to do different operations. So these type of arrangements are called bed mills, and this gantry mill is also comes under this bed mill category. And then we have box mill or column mill. So these are very hobbyist bench mounted milling machines that features a herd riding up and down on a column or box way. So box mill or column mill, these are very compact milling machines which can be mounted anywhere, and they contains a bench mounted milling machines. Okay, so they are very small, they can be mounted on a bench. Okay, and they can be used to do small operations depending on the size of the workpiece. Okay, so they comes under box mill or column mill milling machines. And then we have C frame milling machine. So these are larger, these are very large milling machines, like industrial production mills comes under this category. They feature a knee and a fixed spindle head. That means they have a knee and fixed spindle. So spindle is fixed here, that is only mobile vertically. So the spindle, which is having only vertical motion, it can move up and down, but it cannot move in any other directions. So this is a knee and fixed spindle type of mill. They are typically much more powerful than turret mill. So we are going to see what are these different types of mills in the coming lectures. So as of now, this milling machine is much more powerful than turret mill. So turret mill is a normal milling machine which is used for average workpieces, and it features a separate hydraulic motor for integral hydraulic power feeds in all directions. So this particular C-frame mill will have a integral hydraulic motor which will move the spindle in different directions with the help of hydraulic energy. Okay, and 20 to 50 horsepower motor is attached in this type of milling machine. So backlash eliminators are almost standard equipment. So backlash is always possible in this C-frame milling mills. C-frame mills, they use large NMTB 40 or 50 tooling. So this 40 or 50 tooling, the tables on C-frame mills are usually 18 by 68 inches or larger to allow multiple parts to be machined at the same time. So C-frame mills are very huge. Okay, they can be used to machine parts that are about 18 inches by 68 inches large. So you can understand the size of this milling machine. The milling machine is very huge. Okay, we can machine a larger workpiece on this. The size of the workpiece could go up to 68 inches. Okay, this is very large milling machine. And then we have floor mill. So floor mill is also another type of milling machine which is responsible for milling the objects, and we are going to see how this floor mill works. So these have a row of rotary tables. Okay, we have multiple rotary tables are possible, and a horizontal pendant spindle mounted on a set of tracks that runs parallelly to the table row. So generally in any milling machine we have a single table, but in this floor mill we have multiple tables. That means we can attach multiple workpieces on each table, and the spindle is also have the capability of moving along these all tables. So it can cover all the tables. It can work on all the different tables on different workpieces. So by this we can use the floor mill for mass production. We can do, or we can manufacture more number of products on the same machine itself, because we have multiple tables that are possible, and the cutting tool also has the capability of moving across multiple tables. These mills have predominantly been converted to CNC, but some can still be found as manual machines, and the spindle carriage moves to each individual table, performs the machining operations, and moves to the next table while the previous table is being set up for the next operation. So that is what we discussed. Initially, if this is table 1, 2 and 3, suppose if the workpiece is initially attached to all three tables, now the spindle is at table 1. So it is machining the object or the workpiece on table 1. Now what happens after the completion of the machining on table 1, the spindle will gradually move to the second table. Now the first table is the workpiece is done, it is machined completely. So this workpiece will be replaced with a new workpiece. In the meanwhile, what happens? The spindle will go to the second table where it will work on the next workpiece. Okay. So here we can manage time. We can save time for replacing the workpiece. Okay. So this is very ergonomical and this is very economical while there is no wastage of time here so that we can produce more amount of products. Okay. So the spindle will work on the first table initially and it will go to the second table. Meanwhile, we can change the workpiece on the first table with a new workpiece so that the machine after it goes to the third table and again it will come to the first table. So this kind of machining process is mostly seen in the CNC machines. So in CNC machines, we can see similar kind of arrangement. We can do multiple set of operations on different workpieces or by using different types of tools at the same time. So mostly these floor mills are converted into and they are automated into CNC. And unlike other mills, floor mills have movable floor units. Okay, even the floor units can be moved in all directions because these floor mills are very large. They cannot process big workpieces, but they can process multiple workpieces because they have multiple tables. All these tables can be movable. A crane drop massive rotary tables, XY tables, etc. are used in this type of floor mills. Okay, and into position for machining, allowing large and complex custom milling operations. Large and custom milling operations can be easily performed on this floor mill. Okay, so this is the type of milling machine on which we can do multiple workpieces. We can have multiple tables on which we can attach large number of workpieces. Okay. So and then we have gantry mill. So we have said earlier, the gantry mill is a very large milling machine. The milling head rides over two rails which is lie at the each side of the work surface. See here, this milling machine is very large. It is so large that we want to build poles. Upon the poles, we have to lay two rails, just like a railway. Okay. On this railway, we will see the movement of the crane. So this crane itself has the milling tools. Okay. So this can be as big as the workshop. Okay. So this could be the size of the workshop, whereas the milling machine is fixed on the gantry at a height. Okay. So the gantry can move on the rails. So the milling head rides over the two rails, which are at least a side of the work surface. Due to its design, it is usually very small footprint compared to the machine travel size. As downside, they are usually not a rigid. Example, C-frame mills. So because of this hugeness, these are used for only some applications only. We cannot use this drilling machine or milling machine for all the applications. We can use this for only limited applications because it is very big and it needs more power to work. Okay, and then we have horizontal boring mill. So horizontal boring mill is the milling machine on which we can do boring operations very precisely. So as we have said earlier, we have seen different operations on lathe machines like turning, facing, drilling, boring, honing, etc. All those operations can be performed by milling machines also. Even a single milling machine can perform all the operations on lathe. Okay. Now, this horizontal boring mill, which is large, accurate bed horizontal mills that incorporate many features from various machine tools. So, this horizontal boring mill, it contains lot of features that are taken from other machines and they are combinedly kept in a single single machine. So that is horizontal boring mill. So they are predominantly used to create large manufacturing jigs or to modify large high precision parts. Okay, when we want to work on large parts, yet we have to give a much higher precision, we have to go for this horizontal boring mill. Okay, they have a spindle stroke of several feet, and many are equipped with a tailstock to perform very long boring operations without losing accuracy as the bore increases in depth. So, this is particularly a boring machine. It does not only boring but also all other operations can be done on this machine. But boring is the key thing in which this machine can perform better. Okay, for boring particularly, it will have a tailstock which can perform very long boring operations. Okay, so that is why this horizontal boring machine is a very good machine for boring a long holes without losing any accuracy, because long holes will have more depth. So going more deep into the workpiece, we may lose accuracy. But in this horizontal boring mill, we may not lose the accuracy because it is designed in such a way, and it also has a tailstock to support the accuracy. We may not lose the accuracy at any time. And then we have jig borer. So jig borer is also another type of milling machine. Vertical mills that are built to bore holes. Okay, this is a vertical type of machine which is used for milling holes or bore the holes. We know what is boring process. Boring process is nothing but to increase the diameter of the hole or to increase the surface finish of the hole. We will use the process called boring. So in vertical mill, the boring operation can be done, and a very light slot or face milling. They are typically bed mills with a long spindle throw. Okay, so these are very light slot can be done, and face milling also can be done on this machine. And the beds are more accurate, and hand wheels are graduated down to 0.0001. See here how much precision we can arrive, or how much precision we can get from this jig borer. 0.0001. That means this much of higher precision boring can be done on this jig borer. So for getting more accurate boring holes, we can go for this machine. Okay, and then we have knee mill or knee and column mill. It refers to any milling machine whose X and Y table rides up and down the column on a vertically adjustable knee. Okay, so generally we have a table on any milling machine. If this milling machine has also the capability of moving up and down, then the machine, the milling machine can be called as knee milling or knee and column mill. Okay, this is the second type in this slide. And then we have planer style mill. This is also called as plano milling. Large mills built in the same configuration as planers, except with a milling spindle instead of planing head. Okay, large milling machines are built with the same configuration as the planing machines. We have some machines called planers. So in those planing machines, we remove the we replace the milling spindle instead of the planing head. Okay, if we keep the milling spindle in those place, we can use them as planer style milling machines. Okay, so this term is growing dated as planers themselves are largely a thing of the past. So the planing is a old technique which is used for machining of machine tools, machining of different manufacturing parts. So nowadays the planer mills are mostly converted into this milling machine by simply replacing the spindle. Okay, now we have another type of milling machines. They are ram type milling. So ram type milling machines, this can refer to any mill that has a cutting head mounted on a sliding ram. Okay, So this can refer to any mill that has a cutting head mounted on a sliding ram. Okay, we have a sliding ram. On this, we have a mill that is constructed. The spindle can be oriented either vertically or horizontally. In both directions, we can attach the spindle. In practice, most mills with rams also involve swiveling ability. So, where we can see swiveling ability for the mills, those mills comes under this ram type mills. Okay, and whether or not it is called turret mounting, the Bridgeport configuration can be classified as a vertical head ram type mill. Van Norman Machine Tool Company specialized in this type of mills. They are ram type mills through the 20th century. Since the wide dissemination of CNC machines, ram type mills are still made in the first place. Okay, so the ram type mills have the ability to be moved in all directions. It has the swiveling motion capability. So because of this, the company which is manufacturing this ram type mills is now converting or automating their ram type mills for the industry. Okay, and then we have turret mills. So what is a turret mill? More commonly referred to as Bridgeport type milling, and the spindle can be aligned in many different positions for a very versatile, if sometimes somewhat less rigid machine. Okay, so this is also another type of milling machine which is less rigid when compared to other types of machines. That means it can have more flexibility. It can have more flexible motions possible in all directions. Okay, so these are the different types of milling machines which are available in the market. Some machines are having more capability, like they can mill larger workpieces. Some machines have very less capability. They are so small that they can be mounted on a bench. Some milling machines are modified and are converted into CNC machines, and some milling machines are they do not have any application right now, so they are abandoned, like they are left over. Okay, so we are going to study more about these type of milling machines in the coming lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.